Hello and welcome everyone to the next section of Live Coffee Talks presented by Dom Daniel. My name is Julia and today I would like to talk about Azure OpenAI Embeddings model. Moreover, I would like to remind you, if you want to get insights about OpenAI generally, my previous talk was about it and you can find it on our pages on Facebook, LinkedIn and YouTube. So there are cases where we want to use these OpenAI models with our own datasets and documents, but the problem here is that these models have not seen our data within their training phases. And the question is how we can provide our data to these models to make them understand what we are wanting and then come up with the answer. Another problem here is that these models have token limit in their input, so we can't feed all our documents into one prompt. That is why today I will show you an accelerator which can help you to create word embeddings from all your documents and PDF files, which will enable you to find relevant text with word embeddings generated by OpenAI and find the relevant information as well. Now let's move on and see what limitations we have with traditional OpenAI models. So first of all, these models may struggle to capture the nuanced semantics and relationships between data sets, thus resulting in less accurate predictions. Also, these models often work with high-dimensional data, which can be computationally expensive and challenging to process. Moreover, the architecture of these conventional models may not be optimized for transfer learning, which requires extensive fine-tuning. Besides, these models may also struggle to extract different relevant features and patterns within the data, thus resulting in performance issues. The processing of large volumes of data with these AI models can also be challenging, thus resulting in memory limitations and slower training times. And these models, finally, these models are optimized for more specific domains and topics, which makes them less versatile. So that is why OpenAI and consequently Azure OpenAI introduced the idea of word embeddings, which can help to address the limitations of traditional OpenAI models and to improve the efficiency and performance of AI systems. So what are embeddings? Embeddings are numerical vector representations of real-world objects which are designed to capture the relationships, structure, and semantics of the original data, and then transform it into a format which later can be easily processed by machine learning algorithms. By incorporating these models into these embeddings into your model, you can improve the ability to find relevant and accurate answers to questions within your company-specific data. Also, there is one big plus with embeddings, that is they can be used with other types of data as well, such as images, graphs, or user behavior, etc. But today, we will look at it in the context of natural language processing. So moreover, OpenAI Embeddings API takes this concept a step further by offering pre-trained embeddings, which can be used for a variety of NLP tasks. So these embeddings are trained on a massive amount of text data, which can be used to later power a wide range of applications, starting from chatbots or sentiment analysis tools. But how do these embeddings work? Word embeddings, when we send data to the embeddings API, the API returns us an embedding, which is the vector representation of that text string. For example, when we have similar data, their vector representations should also be similar. Also, this API offers to choose from different embeddings model, each with its own weaknesses and strengths. So different OpenAI embeddings models are created to be good at a particular task. For example, similarity embedding is good at capturing semantic similarities between text strings, between two or more pieces of text. On the other hand, text search embedding can be used, for example, to measure whether the long documents are relevant to a short query. Code search embeddings can be used for embedding code snippets and natural language search queries. Here, I would also like to talk about cosine similarity, as Azure OpenAI embeddings are based on this model to compute similarity between documents and the query. So one of the methods to identify similar documents is to count the number of common words between documents, but unfortunately this approach cannot be scaled, as expansion in a document size can lead to a larger number of words, and that is why cosine similarity is considered to be an effective alternative. Now let's see how we can integrate these embeddings with other data management solutions. For this reason, we need to generate embeddings, of course. First of all, we need to convert our data into a numerical representation using OpenAI API. We will send the data to the API. The API will convert this text into an embedding, into the corresponding embedding. And after all, we need to store these embeddings in a suitable data management solution, which can be Azure database, SQL database, Azure Cosmos DB, blob storage, or Azure Data Lake storage. Also, we must keep them in appropriate data storage, which will support processing and storing these numerical vectors effectively. After all, we can process these embeddings with appropriate data processing tools, which can be Azure Databricks or Azure Machine Learning. And finally, we can integrate these processed embeddings with analytics and visualizations tools such as Power BI to get insights and to make data-driven decisions. As we are exploring OpenAI embeddings, it is necessary and essential to consider advantages and disadvantages of these language representations, which can help us to make informed decisions how to use these embeddings in our projects and applications. So the first advantage with OpenAI embeddings is that they have improved similarity measurement, which means that they capture the semantic similarities of text strings. Also, these models can be used with large amounts of data, which can help them to be integrated into enterprise-level applications. These models also can be used for a variety of tasks, such as recommendations, clustering, or anomaly detection. Among the limitations to consider is limited interpretability, as vector representations generated by these embeddings sometimes may be different to interpret, as they exist in high-dimensional spaces. And also, these models can be sensitive to the nature and quality of the input data, which means they are susceptible to issues such as social bias or noise, for example, which can sometimes be harmful. And that is why Microsoft identifies responsible AI principles when working with these AI systems. And the last disadvantage about which I would like to talk is latency. Because sometimes these embeddings can have slower response time. So this was all for the embeddings. Now let's see these embeddings in practice on Azure. For this, let me show you the Azure OpenAI Studio. Here is it. So here you can see that we have two options, charts and completions, but let's choose the completions options. On the right side, you can see the token input limit, about which I have already spoken. And now let's experiment our model. First of all, let's choose deployment model. Let's choose the powerful model, Text DaVinci. And here, I need some sentences. I have already prepared my data, and I need to pass this text into the playground and ask the model to convert the following text into a word embedding. Let me paste it here and hit the generate button. Let's wait. Let's undo it and regenerate it again to have more accurate response. Here is it. Let's copy it and save for later use. Now we need to ask our model to generate another embedding. This time we will pass our model another sentence but with the identical meaning. So let's change this to the weather is rainy, for example. And hit generate. Let me try once more. Let's change this to 8 to give best possible response and hit the generate button. Let's copy it and refresh our OpenAI Studio to have more accurate responses, yes. Now let's change the model and again try to generate a word embedding. Oh, sorry, here I have a typo. That's why. Let's change it and try once more. So here is it. Let's copy this and again save it here. Now I would like to challenge our model and pass another text which is not identical with the previous two texts. So for example, the sky is blue. And generate word embedding. So here is it. Now let's ask our model to compare whether, to find, let's give our model some challenge, ask him to find two similar embeddings among the three embeddings. Now let's copy this prompt and paste it here. Also here we need to pass our word embeddings that we have just copied. So let's copy them again and provide our playground and the second one as well. So here is it. So let's hit generate button. Here you can see that the model was capable of identifying that the first two embeddings are similar. So why am I showing this to you? Because I want to show you that when we are asking a question to our model, the model generates word embedding for that question After all, using similarity measurements, it is going to search the word embeddings into our data, which we have already converted into numerical representations. And when using similarity measurements and when finding the answer using similarity measurements, it gives the proper answer. So the good point here is that we do not need to do all this manually, because there is an accelerator which can help us to do that automatically. Here you can see the architecture. We have a simple web application which is used for, which can be used for an OpenAI enabled document search. Here we use both OpenAI embedding models and another models. But first of all, here we need to upload our documents, which can be in PDF format, docx format, txt. That is, here we have unstructured documents. For this purpose, here we can also use form recognizer to convert, to extract information, raw documents, from raw text from these documents, because here we can have tables, rows, templates, and of course, we can use Azure Translator to translate from one language to another, because here our data may be in another language rather than English. After all, we need to convert our text into word embeddings using Azure OpenAI service. And finally, we need to provide some place to store our embeddings, and that in this case can be Redis, which is very fast. And when the user asks a question, what is happening here? The model tries to find the word embedding in the Redis cache, and using similarity measurements, when it finds the appropriate answer, the appropriate text, it gives the answer to the user. For now, let's see how we can run this application. Here you can see we have multiple options. For example, we can deploy it on Azure, or we can run everything locally in Docker. It is up to you. You can choose whatever you want, but in this case, I have chosen this option. But before deploying these resources, let me tell that you will need some resources. As I have already shown, here you will need Azure Form Recognizer, Translator service, and access to the Azure OpenAI resource. Now let's hit here to deploy to Azure button and see what's going on. So there we go. Here we can see a custom template for deploying our resources. Let me show what configuration do we need here. So first of all, we need to provide our subscription, which already has access to OpenAI service. Also, we need to provide resource group. I will not do it just now because I have already deployed all these resources, but I will show it to you. We must choose the region, prefix, which will be concatenated into all the other resources that will be created. Here we have the Redis name, port. There are other configurations as well, which here we do not need to change. The most important thing here is that we need the OpenAI endpoint, which can be found on the Azure portal. So let me show it to you. Let's go to our OpenAI service. Here you can see that it is the name. Let's copy it and paste it here. Also, we need the OpenAPI key, which can be found under resource management on the keys and endpoints section. And here you can copy it and paste it here. Of course, we do need OpenAI engine, which in our case is Text DaVinci, but you can also change it. So we need this engine, this model to answer users' questions. Or here we can also choose to put the GPT-4 model, for example. We are choosing the deployment type, that is text. Also, we are choosing the embeddings engine, which is in our case text embedding, ADA, the second version. And here we also need to provide form recognizer endpoint and the form recognizer key. So let me show how you can find it here. Let's type in form recognizer, choose our resource, and again under resource management section and under keys and endpoints, you can see the endpoint and key. The same is true of the translator service. Let me type in translator, choose it, and here is it. From here, you can copy and paste it to our custom deployment template. After providing all the necessary configuration, you can hit review and create button, and after passing the validation, all these resources can be deployed to Azure portal. So let me show how many services we will have after this deployment, as there are a lot of. So let's go to the resource group. And here you can see that we have all the necessary resources: application insights to monitor, function app to run some code, the service plan, and the application itself. So let's choose the web app here. And on the right side, you can see the domain. By clicking the domain name, here you can see that our application is up and running. So here you can see that we have two options to do queries. The first one is the standard one, and the second one is the chat option. But before going on, first of all, we need to upload our documents to our application. Here you can see that I have uploaded it, and our documents are also have already been converted, and the embeddings are also added. So I have two documents to challenge our application. The first one is about financial statements of a company, and the other one is about leadership and education. Now let's go back to our model. And ask some queries. Let's start with the chat options first of all. I have already prepared the questions. Let me copy it. First, we will challenge our first text, which is about financial statements. So let's copy it and paste it here. So we are asking the model to give the statement of profit and loss for the year ending 21st March 2017. So here we need to understand whether the model, the embeddings model, will be able to capture the relevant information from our own datasets, which we have already given to the application. We haven't passed it. Let's hit enter. Here we can see that our application is running, processing. Now let's go to our document and find that section. So here is it. Here we have some template, and within the answer, we can see that the model was capable of, the form recognizer was capable of converting the data into a text format. And here you can see that the model even gives the source where it is located. Now let's ask a model another question, which is about the other text. So here we have two options. First of all, we want the model to extract some information and then give summarization on that part of text. So let's hit enter and find that section in the text. So here is our second text. And here is it. Here you can see that this text is large enough, it is big enough. And here you can see that the model gives us the answer using the similarity measurement again, that is the cosine similarity. And besides, the model was capable of summarizing this large text into 3 or 4 sentences. Now let's challenge our application for the last time, and copy our last question and paste it here. Let's hit enter and wait. While waiting, we can find that section in the document. It is located in the 17th page. So let's find it. So here is it. Here you can see that we have some complex template, and let's see whether the model was capable of identifying what we want. So here you can see that we have asked our model to give us information about what is successful school leadership model. And here is the answer. Again, here the form recognizer was capable of extracting the information, and the embeddings model used the same similarity measurement, the cosine similarity, to give answer to the user, that is to us. Also, with this application, we have another options. Here you can see document summarization, conversation, data extraction, and here you can also explore prompts. Also, I would like to show you that with add document section, you can add both single documents and documents in batch. Also, you can pass this application text and add it to our knowledge base, convert it, and compute the embeddings. So this was all for my today's talk. I hope this was useful and informative. Now, if you have any questions, you can contact me via my email or my LinkedIn account. So thank you very much and goodbye.